if I was to try to create a secondary statement.
Would it be not Q of D?
Not Q of D. Correct, sir. Okay? So, X is not small, but now we're talking about dogs. So it would be not Q of D. The first part, we don't have anything plugged in there. Okay? It's just general. The second part, now we're plugging in the dogs. Okay? Nicely done, sir. And then finally, for the conclusion, guys, not P of D, right? Because the last part says dogs are not insects. So it would be not P. And clearly, guys, doesn't that fit the universal modus tollens for this one? Okay, you guys can look at it, and it fits perfectly into there. Okay, so we're going to say this is valid by the modus tollens.
Even though the domains were different, so it doesn't matter. And
Right, because the first one is just for anything. Okay? Like if I said, if brick is an insect, then brick is small. Okay? Or if Toyota is an insect, or whatever it is. We don't know what we're particularly plugging in there. Okay? And remember, it doesn't matter if it makes sense to us in the real world. It's just logically correct. Okay? If it follows the form. Okay? So, does that make sense to everybody, guys? I want you guys to try to separate your real-world definition of logic versus the formal definitions of logic, okay? So that's all we're doing with this. Okay, so last thing we want to do, okay, very similar. Okay. So it says all real numbers, or all rational numbers are real numbers, okay, which is true, all right? And then we have 2I plus 5 is rational, therefore 2I plus 5 is not real. We know the conclusion's true. But are the steps that we took to get to the conclusion true? Probably not. Okay, so let's define a P, let's define a Q. Okay. So, what are our two predicates for, or what's one of our predicates?
X is a rational number?
Yeah, we could say X is rational, or X is an element of rational, couldn't we, guys?
Yep.
Because it could be true or not true. So we could say X is an element of, by the way, what's the symbol for rational, guys? I forgot. Q, because it's the quotient of two integers. And then the second line, and by the way, if you wanted to just write out X is rational, that's fine too, okay? I don't care either way.
X is real.
X is real, which would mean, and if I wanted to write it symbolically, Andre, X is,
Right.
you can't see R.
Yeah, yeah.
Sorry about that, called you off guard. But no, you were right. I saw the hand motions and it worked out. Good enough. There's one other thing that we need, okay? What's the other thing that we need to define, guys? 2I plus 5, okay? I'm going to call that just some sort of number. Believe it or not, for some reason in complex numbers, what do they usually use? Does anybody know what variable they use to represent a complex number? It's usually Z for some reason, which is confusing because they use Z for integers. So for those of you guys that have to suffer through complex analysis ever, I saw this so many times with Z. All right. But they usually reserve X and Y for real parts, and they refer to Z as like the complex part,
Z
or
is
the
also
argument.
integer too, right? Z is also
Well, Z is the set of integers.
set of integers.
For some reason, in complex theory, they use Z to represent a particular complex number. Okay, so it actually makes sense. Well, I'll show you for those of you guys that are interested another time. But you can express a complex number as an angle. I don't know if you guys ever knew that or not, but yeah, in complex theory, you can do that. So, but don't worry about that for right now. So, because you can convert a complex number into a sine and a cosine value by using, I think it's Euler's theorem. But yeah, never mind. Sorry, I'll shut up. I really want to talk about it, but I'll talk about math instead. So if I want to try to go ahead and do this, all real numbers, all rationals are real. How would you guys define that?
P of X. That implies Q of X.
Nice. If it's rational, then it's real.
Mm-hmm.
Okay. Next line would be
P of Z.
P of Z. Okay. So Z is a rational number, and then it says therefore it is not
Q
real.
of Z.
Not Q of Z. Okay. So take a look at that, guys. Make sure that makes sense. Okay. Any questions about how we set that up? Nicely done, sir. Okay. Obviously, that doesn't look like anything, just a hot mess. So you would just say invalid. It's not even a type of error because it doesn't even come up that often. So you would just say invalid, okay, not modus ponens or tollens.
Do we have to write that, or could we just say?
If I ask for a reason as to why, and I think I do, maybe I say why or why not. I don't say why, but just in case I do ask for why. So you just say not modus ponens or, okay. So if it's not a converse error or if it's not an inverse error, that's what you guys would write, okay? All right, questions guys about this one, this stuff? Hopefully not too difficult, maybe a little bit sneaky on the setup, okay, but other than that, I don't think it's too bad for you guys. Okay, another way to be able to determine if universal modus ponens or tollens is true is by using Venn diagrams, okay? And I know Venn diagrams sounds like it's fairly easy, and it should be fairly easy for us, okay? Generally, there's going to be two components to a Venn diagram, okay? So, one of the major components, if I was to draw a Venn diagram logically, okay, this big guy is called the major premise. Okay? And then inside of the major premise, there may or may not be something called a minor premise. Okay? Now, I'm not saying that these all look like this. Okay? You might have several minor premises, you might have several major premises. It's our job to be able to try to construct these graphs. One of the hardest things I think for students is determining what's the major and what's the minor premise, okay? Hopefully after we go through 4 examples, it won't be that big of a deal for you guys, but if it is, just let me know, I'll try to re-explain it to you guys. Okay, so this first guy should be fairly easy, okay? So, all teachers make mistakes, gods never make mistakes, therefore teachers are not gods, depending upon which teacher you talk to, alright? Maybe some of the engineering teachers on campus, not naming any names, but regardless. Okay. So, no, I didn't say any names. You might be right, Don, but regardless. Alright, all teachers make mistakes, alright? Guys, there's 2 predicates going on there, okay? There's going to be X is a teacher, right, and X makes mistakes. Which is the major premise? You got 50-50 shot.
All teachers.
Unfortunately not. Makes mistakes is the big
on the exam.
okay, that's alright, that's why we're doing this now, right? So that's why we take classes, okay? So, if I was to make a Venn diagram out of this, the major premise is people that make mistakes. Okay. How do we know that's the major premise? Because all teachers make mistakes, right guys? So wouldn't all teachers have to be contained in the people that make mistakes? So the minor premise to this would be teachers. And I know teachers comes first, and I know the word all is right next to teachers. That does not make it the major premise.
So the verb should be the major.
Not all the time. You just have to see what's the subset, okay, if you would. Does that make sense, guys? It says all teachers make mistakes, so teachers have to fit into the group of people or things that make mistakes. Okay. Now, we also have gods never make mistakes. Okay, so where do gods go? Outside, right? So right out here, okay, I'm going to put, and I'll use lowercase letter g as to not offend anybody. Although I probably offended somebody by using lowercase letter. I probably offended somebody by standing up here and using a pen that isn't made of like fiberglass or something like that. Regardless, don't give a shit. Okay? This is right. Guys, doesn't it show right there that it's valid? Okay? So, we have teachers, we have make mistakes, we have gods never make mistakes, therefore teachers are not gods, they're outside of that. So guys, we can evidently see that this is valid, okay? So we can say this is valid by diagram. And that's all we have to do. By the way, this is actually an example of universal modus tollens, okay? It's a contrapositive, okay? If you wanted to write it out like we just did the other 4 examples, you could see that.
Oh, so basically when you draw the major and the minor, we have to first focus on the first sentence. Then the second sentence is for gods, whether it falls
That's the particular instantiation. Just like over here, remember we defined several different variables? That's exactly what the second sentence or the second part of this is going to be, the second premise.
Gotcha.
Does that make sense, Art? Okay. Yeah, me too. All right. All polynomial functions are continuous. Again, we don't care if it's true or false. Okay. What's the major premise for this?
Are continuous.
Continuous functions, right? So basically we have continuous functions as the major premise. So right here, we have our continuous functions. And then guys, the minor premise would be what? Polynomial functions. Okay? So, here, right here, we could just have polynomial functions. Okay. So, now you guys caught on really quickly, okay? Whatever the for all is has to be settled inside of the major premise. Okay? 1 over x is not continuous, so, oh, sir.
So is it possible to have like an even broader premise?
There could be, yeah, even majorer premises,
So
or
just
premise.
put another like ring around?
Right, that's correct, if necessary, okay? So, now I'm not saying I'm going to be that being to do that, okay? I'm only going to stick to 2 at the most, okay? Alright, guys, 1 over x is not continuous. Where does 1 over x go?
On the right.
Outside everything, so it looks just like the previous, okay? So, we're going to put 1 over x. It should be y equals 1 over x, but not that it matters that much. Clearly, the conclusion's true, okay? Since 1 over x is not continuous, it cannot be a polynomial function. So once again, I can't really squeeze it in anywhere, but I'm going to valid by diagram. Okay. So guys, if you wanted to prove something true, that's how you'd have to prove it. Okay?
And
Nothing to
if it, the conclusive statement said 1 over x is a polynomial, then we would say that invalid by diagram.
Correct. I'll show you some invalids.
Okay.
There's multiple ways to show invalidity.
Okay.
Okay. All right. Other questions, guys? Okay. So our third example here. Okay. All students eventually study. Chris will eventually study. Therefore, Chris is a student. Okay. Now, if you guys were to write this out symbolically, you would see that this is a converse error. Okay. Because notice what we did was we put the second predicate first, and then the first predicate second is the conclusion. Okay, so that's like begging the conclusion, if you will. Let's just go ahead and draw what we know to draw. Okay, so all students eventually study. What's the major premise? Eventually studies, right, guys? Because all students have to go in there. Okay, so that's eventually studies, and then in here, let's just have students. Chris will eventually study. Where does Chris go? Inside the students, maybe.
You know he at least goes in beside
Oh.
and eventually studies.
Okay, so he could go here, right? But Donnie, what you said isn't wrong. It could go right here as well, right? Because all he says is that Chris eventually studies. So Chris could go and eventually studies. But it doesn't say that he's not a student. Or she. Sorry, he may be gender biased. Okay, so this is our students, and this is Chris.
It does say he's a student. Chris is a student.
It does.
So,
For the conclusion.
so you have to you have to draw both possibilities?
Yes. And I'll explain what that means in a moment. Okay, so eventually studies. I'll get that guy's way in a second. So, which one of those is correct? Both. Which one do we pick? We can't pick both, okay?
You pick
Pick the broader one.
either one.
Well, it's or.
The second one.
Well, we like the second one, but we don't necessarily know if that's true, right?
But the first one.
So we pick the first one.
Well, actually, they're both true, right? We don't know which one to pick. It's an ambiguous case. So, because we don't know which one to pick, we can't state validity, okay? We're basically saying that they're both true, but I can't pinpoint which one to pick, okay? So there's ambiguity that's going on with this, okay? That's where the converse error comes in, okay?
Why can't you assume that the first one's always gonna be true and that's
Oh, you can.
definitely right?
That is correct. This one is definitely true, but this one could be true, okay? So we can't say with certainty which one to pick. That's the problem.
I think what's confusing is it's like an or thing and like
Correct.
the statement's gonna be true.
One of them's true, right?
Yeah.
This one's always true, but this one could be true. So because we don't know which one to pick, there's invalidity there. There's a contradiction.
Anytime you have two possibilities, it's gonna be invalid.
That's exactly right. If you,
So,
that's okay, you're absolutely right there.
okay.
Two possibilities invalid, and they're both correct possibilities. Sorry, I have to make sure that
Anytime
is
there's
true.
two correct possibilities.
Right.
By putting Chris inside with the students, what exactly does that achieve? Like, how does that change the two different?
Oh, okay. Well, this one's not true, right? Because the conclusion is that Chris is a student.
Yes.
But this one is true because it shows that Chris is a student. So we're saying that this one's not valid, but this one is valid.
So when do you pick the second?
Ah, how do we know for sure that? We don't know for sure.
It's just the fact that both of them provide different bits of information. So they
Correct.
both have something that's true in them, but they don't present the whole picture.
Right.
There
Okay.
could be a time where either of them is true.
That's correct. And we just don't know. Okay, does that answer your question?
Yes.
Okay. So basically, guys, what we would say is that this is invalid. Okay. Because there are two possible valid diagrams. So invalid. Yeah, two possible valid diagrams.
Is it invalid in general, or just by using Venn diagram?
It's actually invalid because if you were to do what we did over here, John, we would actually see that it's going to be a converse error. But remember, I asked you to do it by using the Venn diagrams. Okay? So, guys, that's the way I always think about it. If I give you one of these problems on an exam, I would just check it symbolically first, and you already know what the answer is going to be. Then you can use, and you can finagle your Venn diagrams to support